Again, welcome to DSRT 734 class. This lectures cover the addition rule in probability. Our main objective is to determine if two events are mutually exclusive. Also use the addition rule to find the probability of two events. So we said two events are mutually exclusive if they cannot occur at the same time. So two events A and B cannot occur at the same time, then it's mutually exclusive. So in the Venn diagram here, we have event A and B. They are mutually exclusive because they cannot occur at the same time. But in our second Venn diagram on the right, we can see that there's an intersection between A and B. So which means A and B can occur at the same time. So in this case, the A and B are not mutually exclusive. Again, two events are mutually exclusive if they cannot occur at the same time. So here we're going to decide if the events are mutually exclusive. So the example here, we have event A, we roll 3 on a die. Then event B, we roll a 4 on a die. So the solution here, we will say that they are mutually exclusive because when you roll a die, only one side can come at a time. So there's no way we can have 3 and 4 occurring at the same time. So here we roll a die, the first event, we have 3. The second event B, we have 4. These are mutually exclusive because the first event has one outcome, which is 3. Then the second event also has only one outcome, which is 4. These outcomes cannot occur at the same time. And very simple, when we roll a die, only one side will get output, and we get only one output. So the second question here says we should decide if the events are mutually exclusive. Event A, we randomly select a male student, and event B, we randomly select a NSC major. So this can be not mutually exclusive. The reason why it's not mutually exclusive, because we can have a male student and also it's a NSC major. So this is not mutually exclusive. And let's see the solution. Not mutually exclusive because student can be a male and also it can be a NSC major. Now we go to the addition rule. Here we say the addition rule for the probability of A or B. Now addition, we use the term or. And we can remember the previous lectures. Multiplication rule, we use A and B. So here we say the probability that event A or B will occur is probability of A or B equal to probability of A plus probability of B minus probability of A and B. This means they are not mutually exclusive because if we have event A and B and both of them can occur at the same time and also they can occur individually, then this will be the addition rule formula. Now, addition rule for not mutually exclusive will be this formula. Now, for mutually exclusive, which means event A and B cannot occur at the same time. So that means probability of A or B will be probability of A plus probability of B. Again, this formula means addition formula for, again, non-mutually exclusive, which means A and B can occur at the same time. Now here we say for mutually exclusive event A and B, then the rule can be simplified as probability of A or B is equal to probability of A plus probability of B. Again, because probability of A and B, the event A and B are, again, not, they are mutually exclusive. They cannot occur at the same time. The first formula again, probability of A plus probability of B minus probability of A and B. They can occur, A and B event can occur at the same time. So they are, again, not mutually exclusive. Now let's see an example here using the addition rule. Here they say you select a card from a standard deck find the probability that the card is 4 or an essay. So again, we know the total cards is 52 cards. So here we say the events are mutually exclusive because if the card is a 4, it cannot be an essay at the same time. They have to be two separate cards. So here again, question says we should select a card from a standard deck. Find the probability that the card is a 4 or an essay. So here, all means addition. But first of all, we have to, since we know there are two formulas for the addition, if the event is either mutually exclusive or not mutually exclusive. So first thing we need to determine is the condition here or the events here. Is it possible that it's mutually exclusive or not mutually exclusive? Yes, this will be, again, mutually exclusive because the card 4 cannot be A again or essay. So this means we are going to use the formula probability of 4 or essay is probability of 4 plus probability of essay. Now we know in each card we have a diamond, space, heart, and club. So the possible 4 we have, number 4 is 4. The possible essay we have also is 4. So it will be 4 divided by 52 plus 4 divided by 52, which will give us 8 over 52, and roughly to be 0.154. And also we can see from the Venn diagram, we have possible 4 fours. The diamond, heart, club, and spades. Same thing with the A. We still have that heart, diamond, club, and spades also. And we know the total deck is 52. So that's why we divide by 52. Again, this is mutually exclusive. That's why we use the formula probability of 4 plus probability of essay. Now let's see another example using addition rule. Here they say we should roll a die. Now we should find the probability of rolling a number less than 3 or rolling an odd number. Here we need to be very careful because roll less than 3, we know a die size starts from 1 to 6. So less than 3 means we get only 1 and 2. But also the odd numbers will be 1, 3, and 5. So here we can see that 3 and 1 can occur for probability that we roll less than 3, 1 occur. Also, possible of getting odd, 1 can occur also because 1 is a odd number. In odd number, we have again 1, 3, and 5. So let's see the solution. Here we can see the Venn diagram. 1 can be a odd number, and also it's a value less than 3. So 1 can occur on both sides. So here we say that the events are not mutually exclusive. Why? Because again, 1 is an outcome of both events. So here to find the probability of having less than 3 or odd, we have to use the formula that is not mutually exclusive. So it will be probability of less than 3 plus probability of odd minus probability of less than 3 and odd. And from the Venn diagram, we can see that less than 3 and odd is 1. Only 1 item. So the possible odd we have now is 2. Is 3, the odd numbers. Then we also have less than 3. We have 2 over 6 plus 3 over 6. Because we have to count the 1 also. That's why we minus by 1/6. So for example, odd will be 1, 2, 3. Less than 3 also will be 1, 2. So 2 over 6. And the reason why we are using 6, again, the die have total of 6 sides. So 2 over 6 plus 3 over 6 minus 1 over 6. And that gives us roughly 0.667. Now let's try another example here using the addition rule. Here they say a frequency distribution shows the volume of cells in dollars. So the first column is cells volume in dollars. And also the number of months a cell representative reached each cell level during the past 3 years. So the values on the second column are the months. Now, if this sales pattern continues, the question is, what is the probability that the sales rep will sell between 75,000 and 124,099? So we have to look. We can see 75,000 started here at 7 months sessions, then up to 124. So it will end somewhere here, 75 to 124. So let's see the solution. Here we say the monthly sales between 75,000 to 99,000, which is our first row, which the condition met. We will represent it as A. Then B will be the second, which is 100,000 to 124. So our question is, what is the probability that it will be between 75,000 to 124 and 99? Let's go to the question one more time. They say, what is the probability that the sales rep will sell between 75,000 to 125,999? So we got those two columns. So this means probability of A or B, which is 75,000 all the way to 124, is equal to probability of A plus probability of B. Now, probability of A, we had the number of months was 7. And the period is 3 years, so 7 over 36. Then the second value also 9. 9 months divided by 36. We add the two together. Again, why we are using 36, we can see from the question. They said the number of months a sales rep reach each sales level during the past 3 years. So the total months is 3 years period. So that's why we have 7 months over 36 months plus 9 over 36 months. So roughly, the answer will be 0.444. Now let's try one more example using the addition rule. Here they say a broad bank catalogs the types of broad given by donors during the last 5 days. So we have again, and then the donor is selected at random. Find the probability that the donor has type O or type A. So we can see type O, type A, B, and also type AB. And for RH positive, we have 344. For RH negative, we have 65. And the total will give us 409. This 409 will be the total of everything, the participants. So when we add 344 and 65, we should get 409. That's total. Now the question says we should find the probability that the donor has type O or type A. So we have type O here or type A. So what's the probability of having type O? It doesn't matter whether it's RH or positive or RH negative. We know type O total is 184. Type A total also is 164. And the actual answer is 409. First thing we need to do is to determine if this is mutually exclusive or not mutually exclusive. Of course, this is mutually exclusive because a person cannot have 2 blood types. So either my blood type is type O or type A. It cannot be both. So this means to find the probability that a person have type O or type A based on the data given to us in the table. It will be probability of type O plus probability of type A. Again, this is mutually exclusive. One person cannot have 2 blood types, only one. So the total, as we said, type O is 184. So it will be 184 divided by the total, which is 409, plus type A total is 164 divided by 409. So that roughly will give us 0.851. Again, solving these addition rules, one of the first things we should know whether the condition or the events are mutually exclusive or it's not mutually exclusive. Then based on that, again, we can be able to solve the problem. So next, they say find the probability that the donor has type B or is Rh negative. Okay, so this time we have type B and Rh negative is across. The total for that is 65. But again, type B and Rh is 8. So we have to be careful here. Is this mutually exclusive or not? So here, the events are not mutually exclusive because across, I can have type B. So here we say donor can have type B and also it can be Rh negative. So it's not mutually exclusive. So this means we have to use the formula that probability of type A plus probability of Rh negative minus probability of type A and Rh negative. Because again, it's not mutually exclusive. So we have to subtract and the probability that the two events will occur at the same time. And based on here, we can see from the table, Rh negative and type B, we have 8. So we have to say minus 8 over 409. Then the type B total is 45. So we have 45 over 409 plus Rh negative, the total is 65. So we have 65 divided by 409. Then probability that both events will occur, type B and Rh negative. As we see, the table is 8. So it will be minus 8 over 409 total. So that's what we have here. Approximately, we get 0.249. Again, 45 over 409 because this is not mutually exclusive. So probability of type A or Rh negative will be probability of type A plus probability of Rh negative minus probability of type B and Rh negative. We minus where both events occur at the same time. Both events occur at the same time is 8. So we divide 8 by 409. For type B is 45. For Rh negative is 65. So we get 45 over 409 plus 65 over 409 minus 8 over 409, which is here. So that will be the conclusion of our lectures. Again, these lectures, we focus on probabilities, what is a mutually exclusive event, and also using the addition rule. And we saw that using the addition rule, if the events are mutually exclusive, the formula is a little bit different from if they are not mutually exclusive. So again, wish everybody the best and see you in the next lectures.